Okay, today we're going to talk a little bit about a guy called Sir Isaac Newton. Isaac Newton was an English physicist and a mathematician in the 1700s who was highly regarded for one of the books he wrote, which is The Principles of Math and Physics, as well as how he explained motion. And he came up with 3 laws to describe how things move and why they move the way they move on Earth and in our solar system, as well as in the universe. So there's a little bit of information on him. We're going to start today's, that's him, right there. And somebody said, oh, he was sitting under the apple tree and the apple fell down, hit him on the head, and he said, oh, it's gravity. Well, there you go. A little tidbit about Sir Isaac Newton. All right. We're starting off with Newton's first law of motion. So if you please follow along with me, we'll get this workshop started here. So I'm going to talk about Newton's first law of motion. Oh, by the way, he was not always considered a sir. If you don't know, that's a title given by the Queen of England to some of her subjects depending on what they did and what their contributions were. His contributions were so great in science that he was knighted by the Queen and got the title Sir. So he was not always a sir. See, you can become royalty if you do something really special. There you go. All right. So his first law of motion reads, an object at rest will stay at rest unless an unbalanced force acts on it, and an object in motion will stay in motion unless acted upon by an unbalanced force. So we're going to write that down. An object at rest means it's just not moving, will remain at rest unless acted upon by an unbalanced force So that was part 1, and then part 2 of it says an object in motion will remain in motion, meaning moving. Object is going to stay moving. Will remain in motion unless acted upon by, you guessed it, an unbalanced force. Alright, so the first thing that stands out here is that objects, no matter if they're moving or not, objects will keep doing whatever they're doing no matter what, unless they're acted upon by this unbalanced force. So objects will keep doing what they're doing. And then that big one, of course, unless. And now let's go to unless. Unless acted upon by an unbalanced force. Well, and in order to understand all of this, the first thing we need to understand is, what is a force? What's a force? Well, a force, of course, is called a push or a pull. Pushes and pulls are forces. So in other words, the force that keeps us grounded on Earth is gravity. And is it a pushing or a pulling force? Well, yes, it is a pulling force. It's pulling us towards the center of the earth, okay? So that's an example of a force. All forces are pushes or pulls. So essentially what he's saying, objects will keep doing whatever they are doing unless they're acted upon by these forces. So if these objects want to keep doing what they're doing, this phenomenon is called inertia. So inertia, no, I don't like that one. Let me find another one. Inertia says objects do not want to change what they're doing. Okay, that's the definition basically. Objects resist changes in motion. So oftentimes Newton's first law is called the law of inertia. So Newton's first law is equal to the law of inertia, because it basically all says the same thing. Objects resist change in motion. They want to keep doing whatever they're doing. They won't change their motion unless they are acted on by an unbalanced force. So if I am not moving, this pin is not moving, it's not going to start moving unless it's acted upon by a force, a push or a pull. I'm pulling it up to use it. That's a force. That changed its motion. So let's define balanced versus unbalanced, because that's something that's big in this idea of objects resist change in motion, or Newton's first law. What does he mean by unbalanced? So what does he mean by balanced? Well, let's figure it out. So let's do a little T-chart here about balanced versus unbalanced forces. I'm going to put forces on the top, because forces can be, are a push or a pull, but the forces acting on an object could be balanced or they could be unbalanced. So what does that mean? Okay, so first of all, let's talk about balanced forces. When balanced forces are acting on an object, it will be resulting in no change in motion. So balanced forces result in no change in motion. Well, what do I mean when I say no change in motion? Well, meaning, of course, if it's moving, is it going to stop moving? Well, it says no change in motion, so objects that are moving will do what? That are moving will continue to move. Continue. Good Lord. Continue to move. And objects that are not moving, well, they're going to not move. Objects not moving will not move, or will not start to move. So that's basically balanced forces. No change in motion. If it's moving, it's going to continue. If it ain't moving, it's not starting. Okay? So what does he mean by unbalanced forces then? Well, he means that unbalanced forces are going to, if you guessed change motion, you are absolutely right. So unbalanced forces result in change of motion. So, what does that mean exactly? Well, if it wasn't moving before, it may start moving. If it was moving already, it might slow down. It might change motion altogether. If it was moving, it might stop moving. And if it's a change in motion, it might change its direction that it's moving in. So all of these are a change in motion. Okay? So let's look at some examples of this so that we can better understand. All right, let's take, for example, the Earth. So the Earth is, as we know, constantly rotating on an axis and constantly revolving around the sun. So this motion is constant. It is not changing. So the forces acting on our Earth as it continues its journey around the sun as well as around its own axis is what? Balanced or unbalanced? Well, if we go back to our examples, we said that balanced forces result in no change in motion. So an example then, let's do this. An example, balanced forces is the motion of our Earth. As it rotates on its axis and revolves in an orbit around the sun, right? Okay, so that's not going to change. So in other words, our Earth's going to keep doing what it's doing until what? What has to change its motion? If you said unbalanced force, you're absolutely right. So in order to change the motion of our Earth, what it's doing, something is going to have to act upon it and change it. Another force. And those forces that change motion we call unbalanced forces. So unbalanced forces change the motion. So let's use the pen as an example this time. So the pen's still sitting there. I have to apply a force, a push or a pull. I could push, I could pull, but that's the only thing that's going to change its motion. So unbalanced forces change the motion, and we're going to say the pen won't move unless I apply a push or a pull or a force, and we call those an unbalanced force to move it. All right? So I hope right about now we're feeling pretty good. Okay, so let's think about a game of tug of war as an example. So let's say we had a game of tug of war going on here today. And you had two teams. And you had, let's say, 3 guys here. And against 4 girls. And I'm not drawing the people, but here's the rope. And they're holding on here, and they're holding on here. So, let's say the first scenario is the rope or people are not moving. Well, they're pulling on the rope, but the rope's just staying taut. They're pulling and pulling and pulling on either side, but nothing's moving yet. So neither side is won. So if there's no change in motion here, we would say the forces are what? Balanced. All right, same scenario now. But now, here we got our 3 guys and our 4 girls. Let's say we got another guy to join in. So now we have 4 guys pulling on the rope. And over here we have 4 girls. And sorry, ladies, but we all know the guys are a little bit stronger than us. So the actual motion of the rope and the girls is going this way towards the guys. Now things are moving. Everything's moving in this direction because the guys are out pulling the girls. So if the rope is moving and people are moving, now we have a scenario where the forces are no longer balanced because there's an additional force here that's helping this to get this tug of war game won. So now we're going to say the forces are what? They're moving, changing motion. A change in motion is occurring. They are now unbalanced. All right. So make sure you tune into the next lesson for how to calculate net force.